Solving one-step equations means there's one step to find the unknown variable. It's 4 different types. I could have a plus 12 equals 15. To solve for a, I'm going to need to isolate the variable. That means get the variable by itself. So I'm going to undo whatever operations are being done. If I have a plus 12, the inverse would be a minus 12. So I'm going to do minus 12 on both sides. Now 12 minus 12 is nothing, so I'm left with just a, which is our goal, a by itself, and then 15 minus 12 is 3. So a equals 3. To check this, I would plug in my answer to the original equation. So 3 plus 12, does that equal 15? Yep, 15 equals 15. So we did it correctly. Let's look at 3 more examples. If I have b minus 9 equals negative 2, minus 9, inverse would be add 9. So minus 2 plus 9, different signs subtract, keep the sign of the bigger number. B is going to be 7. I can plug in to check. So 7 minus 9, does that equal negative 2? I can rewrite this as 7 plus negative 9. So I get negative 2 equals negative 2. We could say C over 4 equals 12. Now over is another way to describe division. So C divided by 4 is 12. Inverse of dividing is multiplying. So I could if I'm going to do the inverse, I'm going to multiply both sides by 4. Now technically I can do 4 over 1. That allows me to cross out the 4's using my cross canceling. So this is going to be C equals 48. To check, I would plug it in. So 48 over 4, does that equal 12? Yep, 12 equals 12, so I did it correctly. Last example, 3d equals negative 9. This means multiply when we have a number next to a letter, number next to a variable. So 3d equals negative 9. Inverse of multiplying is dividing. So I'm going to divide both sides by 3. 3 divided by 3 is 1. So I get d equals negative 3. To check, I can plug in my answer. 3 times negative 3. Does that equal negative 9? Yep, negative 9 equals negative 9, so I did it correctly.